All right, welcome to The Explainer. We're already surrounded by AI, right? They're writing code, doing research, running our workflows. It's incredible. But there's this huge challenge brewing just under the surface. And getting it right could unlock everything, while getting it wrong, well, it could trap them all in their own little digital islands.
So the big question is, how do they actually talk to each other? How do they coordinate? How does an AI agent from, say, Google work with one from Anthropic? And look, this isn't just some nerdy technical puzzle. It's the key. It's what could unlock a future where, whole teams of AIs work together across the globe to solve some of our biggest problems.
Because without some kind of common language, we're basically building a digital Tower of Babel. You've got all these super smart agents, but they're just isolated islands of intelligence. And if we want them to team up on the really complex stuff, well, those islands need bridges. They need a standard way to communicate.
And that right there is where the race begins. We've got three major protocols that have popped up from some of the biggest names in the game. You've got MCP from Anthropic, ACP from BEI and IBM, and A2A from Google. And each one has a totally different take on how to solve this massive communication puzzle.
Okay, let's dive in. First up, we've got MCP, the Model Context Protocol. And honestly, to really get what this thing does, you just need to remember one super simple but powerful analogy.
Anthropic, the folks who made it, they call it the USB-C port for AI. And that's just a brilliant way to think about it, isn't it? I mean, think about a USB port. It's this universal standard that lets you plug pretty much any device into your computer. Well, MCP is basically that, but for AI. It's a standard way to plug in tools, data sources, APIs, you name it, directly into a large language model. Now, here's a key detail. Notice that MCP is a model protocol. Its whole job is to feed information into the AI's brain. It's setting up a standard way for a model to, say, access a file, or query a database, or call a service. It's all about giving that AI context and tools to work with. And this distinction is absolutely critical. Think of it like this. MCP connects a brain to its hands and its eyes, its tools. The other protocols we're about to look at, they're designed to connect one brain to another brain. See? They're solving a completely different problem. All right, so if MCP is all about giving an AI its tools, then ACP and A2A are all about letting AIs actually talk to each other. These are true agent protocols, and they're built for those peer-to-peer conversations where different agents can team up, negotiate, and actually work together. Okay, let's start with ACP, which comes from IBM and BI. The best way to think about this one is as the language for a local team. It's built for these decentralized, super high-speed situations where agents have to talk directly with zero reliance on the cloud. So picture this, a whole fleet of rescue drones coordinating a search in some remote area with no internet, or maybe smart robots on a factory floor all collaborating on an assembly line. That's the world ACP was designed for. Now, on the complete opposite end of the spectrum, you have A2A, Google's protocol. So if ACP is for that local team, then A2A is all about global diplomacy. Its entire purpose is to let agents from totally different companies on totally different platforms talk to each other over the internet. And it uses this really clever system called agent cards, which are basically just digital business cards. They let an agent advertise what it can do so other agents can find it and connect with it securely. So, okay, we have a model protocol and two very different agent protocols. It would be really easy to think they're all in this big fight to become the one standard, right? But the reality is actually way more interesting. This isn't a battle, it's an ecosystem.
One analysis put it perfectly. Trying to compare MCP to the others is like comparing apples to oranges. Sure, they're both called protocols, but they solve completely different problems. One helps an AI use its tools, the others help an AI talk to its buddies. They're just operating on totally different layers of the whole AI stack.
And this table here really lays it all out pretty clearly. Just look at the primary focus row. You can see it right there. MCP is all about getting data into a model. ACP is for that local multi-agent teamwork. And A2A is built for collaboration across different companies.
And because of that, you get these totally different use cases, right? You'd use MCP to hook up a knowledge base, you'd use ACP for that fleet of offline drones we mentioned, and you'd use A2A to, let's say, a custom agent you built in one framework, call up a specialized agent from Google.
In fact, far from competing, something like MCP and A2A are actually like perfect puzzle pieces that fit together. Just imagine an agent using MCP to read an internal company document. Then it uses A2A to go out and hire a specialized translation agent from a completely different service to translate that doc into 3 languages. See? One protocol for its tools and another for teamwork.
So look, if this all feels a little complex, here is the absolute simplest way to lock it into your brain. First, think of MCP. Its job is to connect an AI to its tools. That's it. It's the input channel. It's the AI's eyes and ears. And then you have a protocol like A2A, which connects that same AI to other AIs. That's the language of collaboration. It's the handshake that lets 2 different digital minds actually team up.
So, where does all this leave us? I mean, this whole landscape is super new, and it's changing fast. What does the future of AI communication actually look like? Well, broadly speaking, there are probably 3 ways this could go. You've got the dream scenario, convergence, where a single unified standard comes out on top. Then there's the nightmare, fragmentation, a world full of digital walled gardens where agents from different companies can't talk to each other. But the most likely outcome is probably somewhere in the middle, where smart middleware tools act like a universal translator, bridging the gaps between all these different protocols. So what does this mean for you if you're building with AI today? It means there is no single best protocol. It's all about picking the right tool for the job. Are you just hooking up data to a model? MCP is your answer. Are you trying to coordinate a bunch of local robots? You're going to look at ACP. And if you need to connect agents across the cloud, A2A is what you'll be needing. And all of this leaves us with the huge looming question for the future of AI. The choices that developers and the big tech giants are making right now will decide everything. Are we building a truly interconnected, collaborative AI world? Or are we building a fragmented digital world of isolated intelligences? The secret languages of AI are being written as we speak, and the final script is still a total mystery.